school several times before. And I think he was in principle interested, but various things happened. Pandemics happened and various things.
Various children.
Yeah. So we're very, very happy to have Oskar here today. Oskar is not an academic like some of us, and also not a research director at a giant multinational games company like some others of us. Instead, I think this year we don't have that many people from the indie space, but I guess he's our main indie representative today. So Oskar is famous, among other things, for two games, Townscaper and Bad North. They are quite different in various ways, but they have some similarities in how in their reliance on PCG. And we asked Oskar to come to talk about what he wanted to talk about, assuming that what he wanted to talk about was how to build games around PCG and PCG methods around this. So without further ado, welcome, Oskar.
All right. Yeah, so you know how when you go see a band, all the fans just want to hear when you go see a band, all the fans just want to hear all the hits, and then the band goes, and here's a song from our new album. That's what this talk's going to be. So this is a new thing I'm working on. It's like a cool little procedural island generator that generates cool, nice looking islands that I'm probably eventually going to put a game on top of. But I'm not in a hurry, so I'm sort of taking my time, just making them look beautiful in more ways. So I'll show you a little bit the stuff I've been working on before, because this is all kind of, I keep building on the same kind of technology. This is Townscaper. It's the last game I made. It's barely a game even. You just sort of click, you pick colors, and then there's a bunch of algorithms running underneath that's making sure that sort of however you build, it makes sense. And there's like little details filling out the space. You can do things like building little green backyards and whatever, making cool like floating structure, stuff like that. And then before that, I made the game Bad North. Here I just have some random YouTube video of what that game looks like. The new thing I'm building is probably going to be a lot more like Bad North than Townscaper, because Townscaper is an interactive generative game, right? You can keep building, and that kind of limits the kind of algorithms that you can implement, right? Because everything has to be updated instantly. That's one thing. So it has to be fairly fast. It's harder to do global things like doing a UV mapping of the whole world, for example, if it keeps changing all the time. And also there's some design restrictions as well, because if you're making something like Townscaper where the player has to have a fairly good idea of sort of what's going to happen when they do different things, I can, with my algorithms, play a little bit with like the shape of the tiles and surprise the player. But if they place a house block, it should look like a block and it should be a house. Like I can't turn the whole thing into a tree unless I figure out like a very clear way of communicating to the player why this happened and not another thing. So that sort of limits the kind of, there's a bunch of architectural features, for example, that would fit very well into Townscaper, but I haven't figured out a good way of doing sort of recipes for the player on how to construct these different things. There's also, after Townscaper's all urban environments. There's a tiny bit of green space, but it's all within the context of an urban environment. But I wanted to get back to doing some more sort of natural landscapes like in Bad North, and I had some new cool technologies and stuff in mind that I thought would work well. So we'll sort of go through the generation process fairly linearly on what happens when you make one of these levels. Let's just make a couple of more just to see what kind of it's capable of. So first of all, there's the grid, and sort of when I mean Townscaper, that has a weird grid as well. You can tell it's not square here. We got this big weird hexagonal thing going on. So I kind of felt after having introduced that kind of grid, I couldn't go back to doing normal grids. So now I'm stuck with doing weird grids in whatever projects I make in the future. But you can see in the middle here, the grid is kind of square, right? that makes a lot of sense. But then up here at the edges, there's some different things going on. So we can actually overlay what sort of will be the game tiles. So in Bad North, that's in Bad North, it's a tile-based game, but it's only tile-based for the player. So the player tells units where to go, but the units themselves flow freely across the terrain. So it's kind of an interesting differentiation in the abstraction level that the player is working on and that the actually units fighting are working on. And that also means that, like normal tile-based games, it's super important which tiles are adjacent and which aren't adjacent, right? If you're doing melee combat on a square grid, then like what happens on the diagonals, that's unclear. But in a game like this, it doesn't really matter at all. You can have like thin winding paths going between different tiles. The only important part is that it should be easy to send units to go through all the different paths to clear out if there are enemies standing there, because the enemies, they don't care about the tiles at all. But yeah, so Bad North was all square. That was before I started doing weird grids at all. But Townscaper, or this thing here, which might become Bad North 2, we'll see, has this kind of grid. Let's generate some new ones to see what's going on. Yeah, so you see there's a bunch of sort of squarish things going on, but then there's a bunch of more hex-like or kind of irregular grid shapes going on. And what's actually happening, if we take a look at, the first thing that happens in the generation is the base grid being generated. And if we slow down that, we should be able to, here we see the base grid being generated. So I start with like a convex shape. I place a bunch of tiles or a bunch of vertices in the shape in a mostly square pattern, and then I just fill it out with triangles where it didn't fit anything. So then you get a nice mix of squares and triangles. And as we all know, is everyone familiar with the dual graph concept? No, maybe not. There is, when you're doing a hexagon game, you could make all the game tiles be actual hexagons, but hexagons are tricky because they have 6 sides and 6 corners, so that's a lot of work. What you could do instead is you could make all your visual tiles out of the little triangles, combining different like hexagons like this, because that's super convenient, because then you can, like within the like say this is a medieval town with a town wall, then within this triangle you can have a wall like that. So then like if you have a triangle that has a wall like that going outwards, and then a triangle with a wall like that going inwards, and then like one triangle without wall, and then one triangle just filled with the town that's supposed to go inside the wall. So it's like town here, it's town here. Then you can create all the different town shapes you would want to on a hex grid without having to do a bunch of different things that you would do if you put it straight on the hex. So yeah, we got this. So we can actually look at as well what happens if we do it in a non-mixed grid. Here is just with a square grid. It's fairly straightforward and boring. There we go. It's a bit unfair, of course, because I built the whole tile set with the mixed grid in mind. So like it's not able to do all the kind of interesting things here. And we can also do it with, let's just do one more, but it's faster. Yeah. And then we could do it with a full triangle grid. So that's essentially a hex grid as well. That's a little bit cooler. Like you get these interesting, it's obviously works better with like cliff faces, for example. They look a lot more natural in a hex grid. But I'd say one drawback of the hex grid is it has this very clear scale to it, right? If you follow a line, like in a civilization game, for example, if you zoom out, you always see these lines, right? This wave of the hex grid size everywhere. And that looks like that works at a certain scale, but if you zoom out more, it starts to look very repetitive and very obvious. I mean, this is an issue with a lot of tile-based solutions. Whereas, of course, squares have a nice feature of you can actually have like lines running along the square. So like the grid scale doesn't show as much, right? You can have straight lines. And so with this solution, with the mixed grid, I get sort of the best of both worlds. And some features, so I've actually chosen specifically to only allow flat planes on the square tiles, because squares kind of feel more natural. And since I'm displaying this as this kind of agricultural landscape with these little like lines between the different tiles, which are supposed to be game tiles you play on, but they also look like different fields, that makes a lot more sense on the square grid. Whereas on on the boundaries, it looks a lot better on the hex grid. So here you get a little bit of best of both worlds. Yeah. And the other big thing that's going on apart from the grid, of course, is the wave function collapse. That's the same sort of algorithm that it's also known as, well, they're probably slightly different, but I maybe should call it model synthesis, which might be the correct name. I'm not exactly. My algorithm is probably so far a spin-off of both of these that it might be called its own thing. But what's going on, and this is the thing I've been working with since Bad North and Townscaper and a long while back as well, is I'm taking all these different, so these are all my tiles that I built in Maya and then export them just as one big triangle soup mesh without any like naming conventions or grouping or anything into Unity. And then I have an import script that parses these things and like divides them up into different tiles and stuff. And you can see I've got a lot of square tiles going on here and a lot of triangular tiles. And then I even have some tiles that sort of, because I can have tiles that stretch across multiple cells, so to speak. So this house here is supposed to sit like half on some squares and half on some triangles. That's pretty fun. And I can do some more, like I think we have an interesting sort of sloping feature here that's supposed to also like fit in a very specific way with like both squares and triangles. So that's good. Then I can get sort of the best of both worlds. Most of the houses and stuff exist on squares, whereas most of the cliff face features and stuff like that exist here in the triangular space. So what the wave function collapse algorithm does, for those who do not know, is that it figures out how to create a coherent level from a set of input tiles. So this is a demo of the wave function collapse algorithm I wrote a while back. So you can see it takes these, this is like the smallest possible version of it that's still a little bit interesting. So you have these input tiles here to the left, and they fit together in specific ways. You can see there's like little bits of text written on the sides here, which is like in this case, that's just based on the colors, on like it's sampling on 3 positions along the tile edge and based on the colors. But you would do this differently depending on how your tile set's supposed to fit together. And then the algorithm just figures out how to fit all these together in a coherent environment. And the way it does is it starts with like everything being possible everywhere. And so here you can see like all of these existing, all these modules existing in all these different slots. And then if you select something that's supposed to go somewhere, so say I want like this little spire to go here, I click there, boom, a bunch of the possibility space collapsed because a bunch of things are no longer possible. There's no like overhangs in this tile set. So if I put the spire there, then there has to be air above it. And below it, there has to be this one because that's the only one that fits there. But then below that one, there's actually a couple of different ones that fits. But they all in turn have to have dirt below them. So that's very convenient. Like this is a mixed initiative version where you can pick some tiles and then you can just tell it to solve the rest. And like technically what's going on is we can make the algorithm run a little bit slower. So if I pick a spire once again, you see it unfolding. And technically what's going on is when you place a tile, what's happening is removing all the other tiles, because like removing possibilities is the core of the algorithm. And every time the last tile with a specific profile facing a side, so in this case, a specific color, for example, is removed, then it tells the cell next door, like, hey, you need to remove everything that relied on this one. So if there's no longer any sky facing the side, then all the sky tiles relying on the sky has to be removed. And that's a recursive function, basically. I mean, you can implement it as a recursive function or as a work list, kind of with an explicit stack as well. And then it does that until there's nothing more to collapse. All the implications have been resolved, and then you get to make another choice. And in this case, like with this kind of tile set, it can't fail, basically. It always succeeds. With more complex environments or complex tile sets, it has some limitations, and it might run into contradictions and fail. Yeah, let's speed up. No, that's fast. Whoop, there we go. So that's the basic of the wave function collapse algorithm. So I have this big import script that analyzes all these terrain tiles, and you can see on the edges of them there are little numbers, and those are basically the sort of profiles of specific sides, and they fit together with other things. So this 21 and 20, they're very close to each other because they're actually mirrors of each other. So they're like calculated and indexed right after each other. And there's also these little faded numbers here. There's a 0, there's a 1, because above here, that's outside, whereas below here, that's all inside. So those are like reserved indexes for these specific cases. So you could have a tile that's just like an empty tile without any mesh that's just 1, 1, 1, 1, 1 everywhere because it's inside entirely. Yeah. So these are sort of, these little numbers are super key to the algorithm, but I sort of, like if you imagine all the, if you have, imagine you have a tile that fits inside a cell like that, and then it has like a shape facing the edge of it. There's a way to sort of create a hash from those edges facing the side, and then there's a bit of sort of art to how you create this hash, because you don't want like mirrored, you want to keep track of mirrored things, and yeah. And then you can index that hash, and then hopefully two shapes that look exactly the same will end up having the exact same hash, and that's good. I do round my verts quite a bit so that you don't run into like precision issues, because like it's all floating points coming from Maya, obviously. I also do a bunch of, although the different triangles in Maya are marked up with different materials, and I'm using that as tags to sort of apply metadata to the triangles. So there are some, like here's a little beach curve here. So these have like a material called grass, and these ones have a material called beach. And then when I analyze the thing, I also check for edges between different kinds of materials. They're also marked up with like, so that I get these, so if we have an entire square tile, for example, we have what's like a big flat plane, for example. Here we got one of those. You see it's got this cross in the middle because these are marked up with like, it's grass, but grass, I call them different colors. So it's like grass yellow, grass green, grass teal, and then maybe that's grass green as well. And then the borders between those become the borders between the tiles in the game. And then also, if I have triangles that stretch across multiple of these sort of underlying grid tiles, these are joined into bigger modules. So this is a big module, right? You can see how it's it has like triangles that stretch across both of those, and then you see the yellow outlines like that. It's, and you see also that the borders between these are negative numbers. That's just how I flag that these are not normal border hashes, but these are like connecting two internal sort of subtiles into one big tile. Yeah, so that's sort of the tile-based part of the algorithm. Let's start up the game again. So another thing I have been really so yeah, another question is like, why would you go for a like normally when people do landscape, like tile-based are very good for architectural environments because they tend to be, they require a lot of specific authoring. But when people do oh, it's in the wrong, there we go. When people do landscapes, they tend to go for sort of softer algorithms for stuff with height fields or voxel-based things like that. That's really good to get organic shapes, but a benefit of doing tile-based things is you kind of know, if you care about things like navigability, where units can go, where they can't go, and you won't want to be able to control that in nice ways. Like you don't want to create pathways that looks like they're wide enough for a unit to go through, but they can't really because it's a bit too narrow, or cliff faces that you don't really know if they're too steep or not steep enough to go up and down. You don't want that for a game. You want the game world to tell you very clearly how you're able to act upon it. And tiles is a very nice way of achieving that, because then you have very clear control over what kind of data goes in. And of course, tiles are also good because you can mark up special things like places where props would go, or where like houses, mark them up as being houses and where the door is supposed to be, and stuff like that. And here we can turn on the, and it's easier to do, like obviously like something like this wouldn't work on a height field, but it's fairly straightforward to do with a tile-based solution. Here we can mark up and see the borders between the modules that make up these. So these are like the borders between the tiles that you saw in the last picture. And you can see that they have, if we turn on the game tiles where you would move units to, if this was Bad North, you can see that they are, they have this this dual relationship to each other. You see the black lines and the white lines are sort of perpendicular to each other. And you also see right now that these lines are not straight at all. They're kind of wonky, because that's the next part I was going to talk about. When the one thing I wasn't really able to do in Townscaper is I wasn't able to do slopes, right? Townscaper it's all block based. So if you have a block like that and a block like that and a block like that, like there's no, I do put in a little bit of like staircase things going on like this, but sometimes you would want to have a nice slope, and probably a nice sloping slope like that. And Townscaper doesn't have any of that. So that's like one of the things I really wanted to tackle in this project, because you want those for kind of, to create nice, natural, organic environments. So what I did here is I'm actually doing quite a lot of post-processing of the mesh after it's being assembled. So if we turn off all of that post-processing, I do that in 2 steps that I'll go through. We do no deformation and we do no relaxation. And then we generate this same level. There we go. You'll see that some like edges look a lot more jagged. Like here, there's like a sharp turn here where it was basically a smooth straight line before. And if we turn on the module borders, you see that now they're very straight and they conform like very well to the base graph lying underneath. But here also you see this, like this slope here is very clearly like a flat tile and then a slope tile and then a flat tile again. Which is this kind of boring, super obviously tile shapes that I wanted to get away from. So there's actually 2 things going on. First, there's we can turn on the cells, and then we'll look at the cell deformation. There's a face that looks like that, where there's essentially 2 things going on in this. I call it the cell deformation stage. There are kind of 2 things going on. One of the things is that each of the, so if we look at it from above, the cells are trying to achieve the shapes that they had in the modules that went into create, that actually ended up filling them. And that's interesting because some of the modules actually have slightly different, like there's most of the triangles are the same shape, but some of them are a little bit wider, like for example, to make space for a house in between 2 different game tiles where there wasn't really enough space anyway. And also like they obviously have to compromise with their shape to fit together between the different other grid tiles that they're next to. But after the level's been assembled, they know that there's actually air between some of these. So you can see like there's a gap opening up like here between these 2 cells that are actually right next to each other, but there's no mesh connecting them. So they can have a bit more leeway in how they deform. And then there's also if we look at this axis instead, we can see the whole thing's kind of rising up a little bit like that. And that's just a way to add a bit of additional variety to it where if you would have, I'll just clean this a little bit. So what's happening, if you would have like imagine and maybe there's a bit of a stair and then there's like flat, but then there's a sharp wall and it goes down like that. A bit of that kind of shape. What I'm doing is I'm kind of pulling everything upwards, but then it's kind of clamped down with the other things next to it. But it's clamping down more where you can go. So it's kind of tethered where you can go but not tethered on just cliff faces. So what's going to happen to that shape during the relaxation stage is like it's going to rise a little bit here, and then the staircase is going to rise a little bit as well. But then it's going to be able to rise like quite a lot in this direction and go down like that, and then just like rise a little bit there. So this like cliff face here actually gets quite a lot larger, and you introduce a new interesting shape sort of that isn't depending on like variation in the input tiles. That also means that if you have a completely flat level, it will instead turn into like something like that, which is, you know, pretty nice. It looks more natural. You get some nice curvature in there, stuff like that. And then the second thing that's going on is we can turn on the relaxation. So this, like a good thing with doing cell deformation is that it keeps the cells have a defined volume and they keep the contents of the cells very intact. Because when you do post-processing on a mesh otherwise, you might end up with like generating degenerative triangles. Like you might end up flipping a triangle upside down or something like that, or making something too narrow, or just like destroying the intricate shapes. But if you do it on the cell scale and then just interpolate the contents of the cell, it's mostly intact, everything inside the cell. But I still want to do, there's still a little bit too much sort of jaggedness, and especially if you look, see if I have any good example. This is sort of an issue I really had in Townscaper as well. If you look at this hexagonal house here, it's got these really weird like concave corners, because that's just like comes from the shape of the grid underneath, and I didn't really have a good way of solving that. But in this one, let's generate a new one that where it's more apparent. Yeah, here we should see one of these concave corners sort of show up here as well. But then I do a bunch of, or a little bit of, I don't dare to do it too much, but post-processing on this, let's turn on the, yeah, let's do that without the cell deformation, but with the relaxation instead. And then let's slow down relaxation, but not cell deformation. So now this wall here turned out like a little bit less concave, a little bit smoother and more natural. Let's run that process. Let's turn on that and that and that. So here we see the wireframe, and also some lines are blacker than others. So that's super important. They are marked as hard edges in the import step. So that's like really important information in the relaxation step that happens now. So if we generate this one more time, we should see this happen slowly. Here you see like everything's a little bit jagged, but then it gets really nicely smoothed out. While I'm at it, touching these verts, I'm also like pushing them a little bit outwards along their normal, just to make the shape a little bit rounder, which, you know, that's a stylistic choice. That's because I want these really cute sort of roundish cliff things going on. So this smoothing step also means that I can take, like if you look at a cliff face from the side, it's like the bottom is here, and then I have the mesh goes like that, but then it goes straight up, and then it goes a little bit inward like that. And here's the borders between the different tiles, and here's like the top of the hill. But when I smooth it out, it turns into something like that instead, which is a much nicer thing, and you don't see where the original sort of borders between the tiles were. And of course, the smoothing step is quite interesting because it, as I said, it cares a lot about where these little black edges are. I call it hierarchical smoothing because different edges and different verts have different hierarchies. So if we just do a super simple smoothing where every vert just gets to pull all the other verts sort of equally, it ends up looking like this. So it looks a little bit crooked and weird. You're adding more noise really than you're removing from with the smoothing, especially like on the, I mean, like a jagged beach like this might be fine. Well, here with the sand, it looks a little bit weird. Like these triangles here are pulling this vert outwards. It looks very, and especially like the houses, they break down like almost entirely because they're not super high poly, so they don't have a lot of sort of geometric weight, I guess you could tell it. So I'm doing this hierarchical smoothing instead, where it's basically like, yeah, there's only some verts get to pull other verts and only along some edges. So a vert that's not special in any kind of way, like this vert here is just in the middle of nothing. That one sort of that's a normal smoothing function that one gets applied. That one just gets pulled to the middle of all its neighbors, sort of. Whereas like this vert here, for example, that's on a hard edge. So it only gets pulled towards this vert and that vert. So then you get something like, if you have like a couple of verts like that, and it's a little bit jagged, but that's a hard edge. And this one actually has like more than 2 hard edges going out. So that's like pinned as a really hard vert that barely gets moved at all. But then this whole thing these will average towards each other, and they don't care at all about whatever soft verts they're connected to in other directions, but those soft verts get pulled like by these things. And then there's actually multiple layers to these because I've got other features going on. So if we turn on here, you'll see that there are some blue edges and some red edges as well. And the red edges, those are the borders between the game tiles, because I want to smooth those out as well, so that they become a lot more legible and smooth and nice. But they have a different hierarchy to them, so that like the hard edges are the highest sort of priority. And then the blue thing here is the border between two different materials. So it's between the beach and the sand. Those are sort of lower priority. And then the red one is the border between different tiles, and those are the lowest priority. And then the ones that don't have any specialness at all are like super low priority. So that means that I can sort of introduce a lot of variation after I assemble the different tiles, and I have a way to provide an intention to my algorithm of how I want to do that. So it matters a lot in Maya how I mark the different edges, like which ones I mark as hard and which ones I mark as soft, and where I have the different material borders and stuff like that. So I retain the sort of the intention of the shape that I gave it, while still being able to do a lot of manipulation after the fact. So that's one thing. Also, when I do here's a cool thing as well. When I'm doing the wave function collapse algorithm, it's a classic challenge if you do any kind of procedural generation, that you want your level to be roughly playable. You want units to be able to go to different parts in the level. So I have this really rudimentary nav graph that's part of the step where I analyze all the different tiles that go into the game. I analyze which edges that are outgoing from the tiles are navigable, and how you're able to navigate between these different meshes, right? Because you might, or edges, because you might have a tile with like a wall in the middle, so you can't go over the wall, but you have to go, like the tile has several navigable separate graphs in it. So when I run the wave function collapse, let's see if it works to slow that down. You'll see how it starts with some navigable parts, and they're different colors initially because they're not connected to each other. So they're part of like different navigable islands. And then it grows probably turn on the cells as well. Yeah, it grows it sort of collapses the possibility space from the edges of the navigability. So it always tries to extend the navigability to place new tiles that makes the player or the units able to go to new places. It doesn't always succeed, but it tries to. And it's fairly, if you give it the right kind of tile set, it's fairly good at sort of climbing up to high points and making little nice, interesting stairs and stuff like that. And it looks, the nav graph you see here looks really primitive and not very nice because it's sort of, I made it in the smallest way possible. So if you have a square tile like this, that's completely navigable, that means that you can enter through this edge, that edge, that edge, that edge, and then I just connect them in the smallest way possible, which is like just like that. So I'm not even connecting them like this because this connection is implied by the other connections. So then the whole thing looks like a little bit messy and ugly, but it serves the purpose. And if I slow this down, if I remove the slowdown and I turn on the nav graph and generate again. Yeah, here you can see as well, there's a little bit of what should be navigability here, a little bit of red thing here, but there's nothing there. Because what's actually happening is I'm running the wave function collapse algorithm twice. First, I'm doing it trying to expand the navigability. Then when I've done that, I'm like, okay, which of these sections were we able to walk to? And then I save those choices, and then I reset the whole algorithm, and then I implement only those choices that like the tiles that you were able to go to, and then I try and create like water or air in all the other places. So here it ended up then not having a little bit of sort of snippet of navigable land, but instead just water, which is like sometimes there are snippets that show up anyway because of just the constraints of the tile sets, but mostly it removes them so that there's not. And that's sort of an aesthetic choice as well. Like you might want to have some snippets, some islands or little pieces, because you could put like there's a couple of them, but you see it used to be bigger, but then it shrank a little bit. And the reason these one appeared as well is because this little sort of river piece is part of the same tile, so it's navigable on this side, but so then it picked it anyway. And here you can see there's quite a lot of navigable area that wasn't used at all and got replaced by water. Yeah. So another thing happening here, of course, is after I've made this made the cool shape of the level. I paint it so that it looks like I do a bunch of procedural texturing, which is also a very nice way of breaking up the tiles, right? So the textures and the UV maps don't come directly from the tiles. Here we can turn on what the color texture looks like on this one. Looks like that. And as you probably are able to see, the textures are kind of painted on like one sort of brush stroke at a time. So if you turn off the text, you should be able to turn off the stamps. There we go. No stamps. Same seed. Yeah, so here's without any special texturing here. I'm just sort of priming it with some base colors going on. Here you can like see how very low poly the mesh is, for example. These lines here, they follow exactly the shape of the mesh. But then like I found very early on in implementing this system, I get a lot of, I come a long way just adding what I call big blotches here, which is basically, I just like paint big brush strokes and just sample the colors and the normals where I paint the brush strokes, but then just paint it on as a big square. Because then you get, like if we see the difference between the, here you have the wireframe, and then these lines just deviate like slightly, make it a little bit more wobbly while largely following the wireframe. So you get a really nice sort of base, especially for the cliffs. I think this is a really nice way of getting like slightly jagged edges that fit very neatly, closely to the shape of the mesh. Like another way to make it look more cliff-like would be to just add tiling textures and stuff like that. But I don't really like those kind of solutions because, especially in the stylized style, they kind of hide the low poly mesh mostly with noise. They don't contain contextual information about the shape of the mesh at that specific point. They're just like a rock noise that goes on top of it. Whereas this actually creates the rock shape out of the actual underlying polygon shape. And then there's a bunch of, and I plan to go a lot further with this as well. There's of course a bunch of other like specialized handwritten paint brushes going on top. So to create these little bush things, they should probably have some like 3D shape to them as well, but it's a good start. And these sort of lines that run along the grass and stuff like that. So there's a lot left to be played with there as well. And another thing I do here, here's the normal map for the whole thing. And here's an interesting thing called the contrast texture, which is because I want to have these little lines between different things. I don't know if anyone has ever experimented with doing these kind of hand-drawn styles where you have lines everywhere. So outlines is a fairly solved problem, but lines internal to objects is actually a fairly difficult way to get right. If you just bake them into the texture, they will look like, they will have a certain scale, and if you zoom out too much, they'll start to disappear, and when you zoom in, they turn large and blurry. That's why I have this contrast texture, where for each edge, it has an idea of how much contrast it wants to have to the edge next to it. So like a hard edge should always have some kind of contrast, and the difference between grass and cliff should always be, that should be an even higher contrast, or like between the roof of a house and the wall of a house. And then I've got this iterative algorithm which just seeds everything with a random color, and then it iteratively goes through and see like, oh, this edge should have more contrast, so let's like push these colors away from each other. Oh, this edge here, they should have less contrast, let's pull these towards each other. You run that like 100 iterations or something, and then you get a nice like super colorful map like the one here. And then if you just run like edge detection on that map, you get super nice outlines with like the right intensity in different places. Yeah. Then I got some nice, like I voxelized this whole space and make a 3-dimensional distance field as well for lighting and for other things. If we see, there we see, that's a beautiful, gorgeous texture. Can anyone guess what that is? It's a 3D texture, sort of, but stacked, right? So these are like the horizontal planes, and then all the 16 ones are like stacked vertically. But the weird colors, because it's actually a distance field in the alpha channel, but you can barely see that. But the weird colors are the UV colors of the closest triangle to that voxel in the distance field. Because that means that I can then, through that distance, through this texture, I can look up the UV mapped mega texture, so I can run my lighting calculations. I can go back and forth between the volume and the unwrapped mega texture as much as I want. Which is, yeah. And then I bake this this is like a baked texture of those, because I figured if this should run on mobile, which so far I put all my games on mobile, so I guess this should run on mobile as well. Doing this kind of expensive lighting calculations and global illumination, it'd be nice if you could just pre-bake this whole thing into one mega texture, then like drawing the whole environment becomes super cheap. But then it's also baked into a big, nice light volume. Here you see that one. Which is like a volume, but it's also with different axes. So you got like the brightest one here is upwards facing, and that the darkest is downward facing. Then it's like left, right, positive, negative. And you can clearly see the sort of shape of the island here as well. And there's actually some shadow casting going on, so I can use that in the to do like I got fairly complex global illumination lighting, but actually rendering that is super simple. I just sample like one place in the in this volumetric texture, and so then I can light particles, grass, foliage, units, whatever, super cheaply. I had a similar solution to Bad North, but it's just like a little bit more complicated this time. Doing on time, pretty good. Yeah, so I think I've gone through most of the major things I wanted to show, so I can start moving to questions. And yeah, I got a lot of the stuff here on the computer if you want to see something.
Thank you. Yes, we can get ready with microphone for questions. See, where do we start? Front here.
Yeah, thank you very much. You know, the texture, sorry, the vertex smoothing.
Yep.
Do you do anything? Do you smooth towards the low priority vertices at all?
No, the higher priorities or order or what you want to call them, they don't move towards the lower ones at all. But the lower ones move towards the higher ones. Yes, yeah. There's a time, and the ones that have more than 2 outgoing hard edges, so the ones like this one, those shouldn't be moved at all by the other ones, but I actually move them just a tiny bit because it creates a little bit. It depends a bit. Like I do a lot of ad hoc stuff, like the houses, they're not smoothed at all because they're created in the correct shape from the beginning. So yeah, there's a bunch of ad hoc stuff like that going on. And like different materials being treated slightly differently, and some are bulging outward a little bit more and some a little bit less and stuff like that.
Thank you very much. This is a bit out there, but given that you're at the output of your algorithm is itself kind of a tile, have you considered running this recursively to create, like, use this as like the tile piece and then extend that into like its own kind of wave function collapse into like a set of island tiles?
I don't think I fully understand.
Oh, sorry. Given that you can generate like a tile,
yeah,
comprised of tiles,
right? Yes.
Could you ostensibly like recurse and generate like a whole archipelago of these guys?
Oh yeah, I mean theoretically you could for sure. Yeah, yeah. I'm probably not gonna, because I like these little really cozy small environments, and it sort of brings out the most of the tile-based approach as well. Because if you've got a very big environment, you can spread things out a lot, and you can sort of. But when you're doing a small cozy environment, things need to butt up against each other and sort of relate to each other a lot. And the handcrafting you get to do when you do a tile-based system kind of caters to that a lot. You get to like little details be leaning on each other and stuff like that. Yeah, so yeah. There's also a bunch of, like, there's a lot of technical things you can get away with when you do a very constrained environment like this, like being able to do the lighting in just one big volume and that's it. Like obviously in a big game that wouldn't work at all. You would have like a loading system and like a bigger volume and then a smaller. I mean, you probably couldn't use that's why you use light probes and similar system. But here it's very defined, small space. I can just have one big volume covering everything, one big UV map covering everything, one big texture covering everything. So it's like a lot of the problems become a lot simpler when you just put everything in a small space like this.
So when you're deciding the tiles, do you have like a different texture for each different tile combination, or do you have like a grass tile kind of, and a portion of it is taken by another texture somehow?
So all the texturing is happening procedurally after the fact. So there's no texturing going into the tiles at all, and there's no UV map on the tiles as they are. So the whole thing is UV map as one, and then so there's no the texture system basically doesn't know much about the tiles at all. That at that point that information has become old and irrelevant, sort of. Which is also why you don't get like the borders between the tiles shouldn't be visible in the. I mean, there are some borders visible here, but they're actually not the borders between the module tiles that go into the game, but they're the borders between the game tiles where you would play the game. So they're sort of intentionally placed there.
So it's like decided after, kind of.
Yeah. The texture is entirely created after the fact. Yeah.
Thank you.
Really fun talk. I wanted to ask you, I think you mentioned already the handcrafted tiles, but you have all this tech going on, and then you actually do these tiles in Maya.
Yeah.
Which is kind of weird, right? Like, you have all this, like, what is the rationale? Why do you do it like the way you're doing it? Is it an aesthetic thing? Or a gameplay
What
thing?
other way would I do it?
You could just generate them, like, you could just generate them, right?
Yeah, but there's a lot of artistic consideration that goes into handcrafting them. A lot of them look like fairly generic in their shapes and just solve like specific geometrical problems. But there's a lot of things about like what happens when different things meet each other, like how a certain little path looks like, and also a big part is like which ones shouldn't be there. There's an awkward connect. That's a big difference between this and Townscaper, because Townscaper, that has to solve for every possible way a person can build, but which actually like negates some of the benefit of the wave function collapse algorithm, because it's supposed to be able to figure out what it can do with it, what it's given. So here's like, if I have an awkward shape, or if there's a theoretical awkward shape where two different things would meet each other, but it looks a little bit weird, I can't solve it in an aesthetical way, I just don't create that one at all. And especially once now I only have a few houses like this. But they have a little bit of special shape to them. Like you see, this one has like a little bit of a path that's sort of tied to the house. This one has a little bit of a foundation that goes out like this. Like these things, you could generate these things kind of in Houdini or something like that. But then you have to write all those aesthetic rules. You have to formulate them into generative functions, which is good for some things. But here you can just bake them in manually, which is good for others. It's much easier to add. I think that especially shows in Townscaper, which has, because in urban environments, it's filled with so many different kinds of objects and things that there would be so many rules if you would generate them. Whereas if you make them manually, it's a lot easier, and you can for everything you can take in consideration. Oh, does this look too busy or too detailed, or maybe good? Do these complement each other in a nice way? So yeah. I mean, I think it's in general with procedurally generated things, it's very easy that they look too procedural generated. You want to get the handcrafted artistic aspect in there somewhere. And a bit of that comes from just writing sort of artisanal code, a lot of hard-coded things on what goes where and stuff like that. But it's good to have some space to do actual sort of manual modeling or texturing as well, yeah.
Hello, thank you for the talk. How do you go from you have many tiles. How do you decide which ones you want to make next, and then that whole process of making it in Maya and then importing it through your custom importer, like deciding hard edges and stuff? How do you keep track of every single tile you already made? And is it just like a very arduous process? Is it very
No, I mean, it's a fairly it's a fairly fun and artistic just thing. It's like you imagine this kind of natural feature, and then you try and make a tile that creates that one, or usually you make like a tile system because you want it to be able to appear in many different ways. So like, yeah, if you have a specific like little sort of small path, then you usually have several like lower parts of the path and several possible higher levels of the path and stuff like that. So that's the kind of work you do at the end of the day when you're tired, and because it's fairly relaxing and you just build a bunch of different shapes, try them out, see what they look like. Actually, a common thing though is that I make some really cool shape, but that requires some very specific context to show up.
Yes.
And then they don't show up for ages. So I should probably write a better system to like ensure that something shows up in some way after I've created it, so I can see that this actually work. But sometimes I've made a piece, try and make it show up, it doesn't show up, and then just like a couple of days later, it's like, oh, there it is. Oh, that looks pretty cool, or that looks bad. I should remove that one. But those are like usually for the pieces that solve for really weird cases, require very specific context to show up. Yeah.
A second question is for the pathing. Is that also part of the importer? Is that
yes, it's part of the
side point?
Yes, analyzing. So it does both all the little triangles, depending on their materials, they know if they're pathable or not. But it takes that information. So in the game that's probably going to end up on top of this, that information will be used straight up, and it will be treated as a nav mesh basically. But the simplified layer of pathing that you see here, that's based on that, but it's like creating the most abstract representative version of that as possible. Yeah. Yeah, so it ignores the internal pathing within a tile, for example, and just sees how it connects to the borders. Yeah.
So Oskar, if you can reveal this, the game that sits on top of this.
Yeah.
So do the players interact with the island as before, or has nothing? The geometry you generate has nothing to do with the game.
Well, so I'm building it with Bad North in mind.
Okay.
Which was this thing, which is so you in that case you send little armies around and they move on the tiles. Yeah. This one wouldn't. A bunch of these systems in this one wouldn't work in a Townscaper style environment because like this global texture, for example, would be basically like it would be a. I mean, you could probably do something where you update it, but it would be tricky to do in that kind of environment.
Hi, Oskar. I'm a fan of Bad North and Townscaper.
Oh, lovely.
I love your game very much.
Thank you.
I want to know when you develop your tools, how do you ensure your functionality will work properly?
I mean, I don't have a special. I just try things and see if they work and try it over and over again. So, like, actually preparing for this talk, because then I needed to, like, most of these things I've built as visualizers as I've developed them. But preparing for this talk, I like polished up the visualizations and like tried to slow down the algorithm in different places. And I discovered a bunch of bugs and things that didn't, like, especially with this pathing thing that didn't work out and all kinds of things. So there's a very good cleansing process and like going through everything again, step by step, and like, oh, this is supposed to be working, but it's not anymore. So there's a lot of that happening because I mean, it's probably even worse with like the neural, like this is a bit of a black boxy algorithm, as I guess is the problem with neural net stuff as well, that you don't, it's black boxy in the way that the data is so big and so abstract that it's very hard to visualize what's going on. So like, why do some possibilities get eliminated from the possibility space? Like, so if there's errors there, it's very hard to catch. You usually have to, if you suspect there's something wrong, you usually have to write specific visualizations for that thing. But a very important part of my process is to visualize the algorithms as I'm writing them, and doing this kind of thing where I deliberately slow down the algorithm and run it step by step to see what's actually happening. That's a good way of catching bugs and seeing if you're doing unnecessary work somewhere, or like, yeah, seeing how things are progressing in general. Yeah.
Maybe I missed this, but how did you get inspired to use wave function collapse / model synthesis for your game development? And do you know of any prior examples in the game space of this algorithm?
I know there are some other ones that do it now. I think I was one of the first ones to do it, like properly, especially for train generation, I think. I actually, like, I've been interested in tile-based procedural generation for a long time, and I'd been thinking about like, how do I get sort of features that stretch across multiple tiles? And I've also been thinking explicitly about like, is there a way to derive constraints from the ways the tiles look to actually figure out what's possible to build from them? And I'd been thinking about that, and then I came across a wave function collapse algorithm. Of course, I don't know how many of you have seen the like original implementation of it, but that's actually doing things on like a pixel art thing. It's not 3D tiles. But since I've been thinking about this problem, I immediately recognized that, oh, this exactly solves the thing I'm trying to figure out. So then I got working 3D thing up and running fairly soon after that. And then I tried to do these beautiful, colorful environments, urban environments like in Townscaper. I didn't manage to put a fun game on top of it because I wanted it to be a nice, peaceful game. Peaceful games are hard. So then I made a violent game instead, Bad North. It's easy to make fun, violent games. But then after Bad North, I was going, no, this time I'm just going to do the beautiful buildings, and I'm not going to put a game on top of it whatsoever. It's just going to be nice and beautiful. Yeah.
I'll jump in. So you mentioned the advantage of pathfinding for this particular approach.
Yes.
Do you feel like you made any artistic compromises by that needing to pathfind? Or to put it the other way, if you had agents that didn't need that pathfinding data but could still move around whatever you generated, would you do anything differently?
I don't know. I mean, because to me, pathfinding is a really aesthetical thing in and of itself, right? You're really intrigued if you see an environment and it's got little staircases or little ladders or stuff like that, and you start to imagine how a person would walk through this space. I mean, like Townscaper isn't, it's not constrained by pathfinding. There's sadly nothing walking around here whatsoever, but there's still like, here's a little ladder going up like this. And I tried to make it sort of believable so that there's not too many ladders and not too few ladders. And there's a bunch of things like that. And there's like little, here's a ladder going up to the side of that house and here's a little stair. So pathfinding is something sort of making it pathable is sort of aesthetic in and of itself. But also, I mean, with any kind of game in mind, that's the pretty core requirement anyway. So yeah, so I've never really thought what I would do if I didn't have to do that. Yeah.
I think this is a nice example, right? Because traditional nav mesh, if you were doing that on this and you're making that deconstruction constantly, it's going to be really hard to rebake that nav mesh every time.
Yeah.
But if you had a bunch of autonomous agents that weren't dependent on a nav mesh or that graph already being there, and that they could just drop in, play it, destroys or builds whatever with your tool, but the agents still naturally traverse through that space.
But also the thing about a tile-based environment is you can keep a nav mesh in the tiles. You don't have to run a normal nav mesh algorithm to reconstruct a huge nav mesh for the whole thing. You can just have little nav mesh snippets, or just in Bad North, I explicitly made little bits of nav mesh that sat on top of the tiles, like as meshes. But in the new project, I'm hoping to just use the mesh as it is. And just because it's already marked up with different materials and what's navigable and what's not. So you actually you sort of just skip all the entire expensive nav mesh generation process altogether. Yeah.
Let's thank Oskar once again.